Welcome one and all to the introductory lesson on solving the measurements of ambiguous cases for a triangle given side-side angle primarily using the law of sines. In previous videos we talked about other cases for solving oblique triangles primarily using the law of sines or the law of cosines. In this case we're going to talk about a unique situation where you have two sides given to you and one angle not between the two sides. So this is going to be SSA or ASS, which I won't say out loud, but it is a unique situation where you can say a word like that out loud in math. What's unique about this case is that it can lead to more than one triangle that you have to solve. Now obviously we need to remember that we are going to use the law of sines, so here's a brief review slide on the law of sines themselves. Remember that you can have it in its original form or its alternative form, and a good strategy is to put the unknown variable in the numerator. So in case you want to find the side, put the missing side on the top of a fraction and put all the other information given to you around that. Or alternatively, if you need to find the angle, then you put the sign of that angle, missing angle on top of a fraction and put everything else around that. So the reason why this is a unique case is because with the given information of side angle, the given angle is fixed, both sides are fixed, but the problem is that we don't know what one of the sides is, in particular the side opposite from the given angle. We don't know what that side is, we don't know the relationship of that side with the missing side. We don't know if it's too short, if it touches once, or if it's long enough so that it can revolve and touch it twice. So we'll see examples of that. So in other words, we have three unique situations where you can have no triangles, one triangle, or two triangles. Now another important piece of information to note is the height of the triangle. In other words, the line, the shortest distance from the top of the triangle to the opposite side. And we represent that by h, but h can be represented by b sine a with the given information, so that we can use the numbers given to us to find the height of a triangle. So here's type 1. If your angle given to you is less than 90 degrees or an acute angle, and the side of opposite from that given angle is shorter than the other side, then you have to compare the side A with the height of the triangle. Because depending on the relationship of those two sides, you can determine how many triangles you have. So for example, the first one is side A, or A, is less than B sine A. If that is the case, you have this first picture where the side is too short and it can't even touch the opposite side, however long that may be, so we know there's no triangle, so there's no solution. If the side A is equal to B sine A, or the height of the triangle, then it creates a perfect right triangle, and there's exactly one triangle that you can solve. However, if the side A is bigger than the height, or the B sine A, but still shorter than the side B, then it creates these two possible triangles right here, where we have one side here to create the big triangle, or it creates this side here where it creates this tiny triangle right here. Now, take the same angle where it's still less than 90 degrees, but the side itself is bigger than or equal to side B. So the opposite side from the given angle is longer or equal to the other side given, then there's only one triangle to solve. Now what do you have if A is actually equal to B? Well, then that creates an isosceles triangles if A is equal to B. So if we were to actually represent that on the graph, it would be this side, this angle A, and this angle B would be equal to each other because the sides themselves are equal. That's again unique situation, and who knows if that actually happens, but if it does, now you know. The last type is what if the angle given to you is bigger than 90 degrees? What if it's an obtuse angle? So you have these two possibilities. Well, this is a lot easier to notify because you don't have to compare it with the height of the triangle, the B sine A, because it's not possible to really create that with the given information. So what if the side A is less than or equal to B itself? Well, if that's the case, then you have this picture here where it's too short, or if it's exactly equal to B, all it does is that if you swing it around, it's equal to B, which would not create a triangle but more of an angle. So therefore, it just stays the way it is. Now, if it's bigger than b, then for a fact, you know that you can create a triangle. And it's example 1 triangle. So the only problem that you might need to be aware of is what if the letters given to you are not the same as the rules themselves? Because our rules depend on being given side A, side B, and angle A, capital A. Well, if that's the situation, then all you have to do is just replace the rules, the letters and the variables in the rules with the ones given to you. And you know which one is which because A and capital A is your complete pair. So a angle and its opposite side, and then B is just the other side given. So putting all those rules together, here it is. So again, if the angle is less than 90 degrees and your angle side A is less than B, then you compare it with B and side A. Those are your different possibilities. And if the angle is bigger than 90 degrees, then here are the different triangles that you could also have. In a different video, we'll talk about how to actually solve the oblique triangles. So if these rules don't necessarily make sense to you, if the visuals didn't really help, the nice thing is that knowing how to solve it can help bypass those rules. The rules are really useful because it can tell you like, oh, this is how many triangles I should expect. So if there's no triangles, I don't need to do anything. If there's one triangle, I just solve exactly one. If there's two, then I have to solve both. These steps, though, will work without having to necessarily memorize the rules, but it is a good way to understand what you're doing and how best to go about solving these problems. So check out the other video on actually how to solve the ambiguous cases of the oblique triangles SSA. There you go.